Alright, so we saved the best example for last. We have log of tan inverse of x plus 1 over x minus 1. So we have three layers here. Log's going to be our outermost layer, that's pretty obvious. Tan inverse is going to be middle layer. And then x plus 1 over x minus 1 is going to be our innermost layer. And the reason that this one is a little bit more advanced is because it requires the quotient rule for our innermost layer. Not too bad though, because we should already know, or we do already know that rule. Now there's really no way to make this derivative easier for step 1, but just remember, anytime you can simplify an expression before you take the derivative, the better off you're going to be. I did actually put that this was log base 10. I forgot to mention that. That way we know we can, that's going to be our a. Remember, the derivative of log base a of x is ln of a times a to the x. That's going to help us know it's going to be ln of 10, right? So there you go. Now which rules are we going to use? We're going to use the chain rule. We're going to use transcendental rule, in other words, the derivative of the log. We're going to be using trigonometric rule, in this case inverse tangent, and the quotient rule, because our innermost function is a fraction. It's a rational function. Okay, so our outermost layer is log base 10. Our middle layer is tan inverse g. Our innermost layer h is x plus 1 over x minus 1. So remember, you're just writing the basic function, so it's log base 10 of all of that stuff that's inside of that just becomes x, right? And then tan inverse of, instead of that fraction, it's just x. And then find the innermost function h of x is x plus 1, x minus 1. So the derivative of log log base 10 of x, I misspoke earlier. I was thinking of the exponential rule. Derivative of log base a of x is 1 over ln of a times x. Okay, that's why the derivative of ln of x is 1 over x, because it's 1 over ln of e times x, which just becomes 1 over x. So the derivative of log base 10 of x is 1 over ln of 10 times x. The derivative of g prime is 1 over 1 plus x squared. That's the reason why I use tan inverse, because the derivative is actually pretty simple compared to some of the other ones. So the derivative of tan inverse is 1 over 1 plus x squared. The derivative of h of x, we have to use the quotient rule, right? I went ahead and labeled those as subcomponents a and b. We know the quotient rule is a prime b minus ab prime over b squared. So let's go ahead and just apply that real quick. That would be my a prime would be 1, b prime would be 1. So I tried to simplify that as well as you can see. So we're just going to plug this stuff in to find the derivative of x plus 1, x minus 1. I'm not going to spend a whole lot of time on that. But when we simplify it, we actually get something pretty interesting. We get negative 2 over x minus 1 squared. So that's our innermost derivative using the quotient rule. Okay, so our f prime, remember, was 1 over ln of 10 times x. Well, instead of x, we're plugging in g of h. So namely, we'll be plugging in tan inverse of x plus 1 over x minus 1, whatever we have left over, times g prime of h. Now remember, we figured out g prime to be 1 over 1 plus x squared. So wherever there's an x right here, I'm going to replace with h, which is x plus 1 over x minus 1. Okay, and for some reason I wrote it as 1 plus x, 1 minus x. I'm not sure why I did that. Okay, so I fixed it now. It's x plus 1, x minus 1. We're plugging that in for the 1 over 1 plus x squared times the derivative of the inside, which we just figured out using the quotient rule to be negative 2 over x minus 1 squared. So now the question becomes, how do we simplify all this? Well, this over here is very messy. There's not much to do there. We could just combine this as one fraction. This is an x minus 1 squared right here on the bottom, which this also has an x minus 1 squared, so it looks to me like those could simplify. So let's go ahead and do that. I'm just going to cancel this x minus 1 squared with this x minus 1 squared. No, actually, you know what? Now I see why we can't do that, because there's a 1 right here. So those won't cancel. We'll just leave it that way. I will briefly talk about the shortcut for this one. I'm not going to write it out, but we'll go back to the original function and see how that will work. Your outermost function is log base 10, so it would be 1 over ln of 10 times x, so you just plug that in, whatever's left over, times the derivative of the inside, which is derivative of tan inverse is 1 over, let's double check and make sure I'm right, 1 plus x squared, so it would be times 1 over 1 plus, instead of the x, you replace it with x plus 1 over x minus 1 squared, times the derivative of the inside, you use the quotient rule. So again, you can use the shortcut as long as you're comfortable with it. But this one kind of illustrates that sometimes you do want to write it out and label your components so you don't get confused. So sometimes the long way is better. Let's take a look at a graph and then we'll be finished with this. Just wanted to remind you of what the derivative is. Remember that, so this red graph right here is the derivative of our original graph. In this case it's 1 minus 2 times x plus 2 cubed, right? But why do we have this? You know, what is the derivative? Well, the derivative function gives you the slope of the tangent line at a specific point. So, for example, if I were to plug in -1 into this red function, it would give me the slope of this orange line, which is -6. So the derivative is important to understand graphically. It gives you the slope of the tangent line at a specific x value of the original graph here being the black graph. I'll leave a link for this app in case you want to use it to graph the derivative and check your work. Right now we're just finding equations, and the next lesson we'll figure out how to plug an x value into an equation to figure out the slope of the tangent line, which is this orange line right here. So once you plug that x value in this case -1, into your derivative graph, this red equation right here, the y value of this red graph would be -6, and it will give you the slope of the tangent line on the original graph, this original f of x equals 1 minus 2 times x plus 2 cubed. You plug into the red function, it gives you slope of the tangent line on that graph, in this case -6. So that's what we're going to learn next. If you have any other questions about the chain rule, let me know.